In this video, we are going to be learning about powers raised to a power. Now, let's review. Remember, an exponent just means repeated multiplication. So like 4 times 4 times 4 could be written, as 4 to the third. Now, what if we had 4 to the second times 4 to the third? Well, 4 to the second is just 4 times 4. And then 4 to the third is 4 times 4 times 4. So if you multiply 4 times 4 with 4 times 4 times 4, multiplying those two, that's like 4 times 4 times 4 times 4 times 4, which is basically 4 to the fifth. And if you remember, all you need to do is add those little powers, the second power and third power, and if you add those two up, you should get 5, which is exactly what we get. Now, what happens when we have a power of another power? So right over here, we've got 9 to the second raised to the third power. Well, 9 to the second raised to the third power is 9 to the second times 9 to the second times 9 to the second. And what is 9 to the second times 9 to the second times 9 to the second? Well, this is 9 times 9. 9 times 9 again, and 9 times 9 again. And that's all being multiplied together. So expanded further is just 9, 2, 3, 4, 5, 6, which is 9 to the sixth. So can you think of how you would get from 2 to 3 to 6? Think about that as we do this next one. We have 8 to the third power times to the fourth power. So we have 8 to the third times 8 to the third times 8 to the third, and it is to the fourth, so 8 to the third again. And what that means is 8 times 8 times 8, that's 1. Let's do the next one, next set. 8 times 8 times 8. And another set of 8 times 8 times 8. And one more set of 8 times 8 times 8. So, and those are all being multiplied together. So you have like 3, 6, 9, 12 eighths being multiplied together. What is that? Well, that is 8 to the 12th. Now, again, looking at these numbers, 2 to 2, 9 to the second raised to the third, got you 6. 8 to the third raised to the fourth, got you 12. Is there any way you can get like 12 from 3 and 4? You've probably already figured it out. But basically, you multiply. You multiply the powers. This one looks weird, but don't worry. It is basically just -6 square 5 times. Remember, we got to put it inside parentheses. So that's 2. That's 3. That's 4. And that's 5. Now, what I can do is just write this like -6 squared is just -6 times -6 times -6 times -6, and ultimately I'd have to do it 10 times. But let's just keep it simple. You've already figured it out. It's -6 in parentheses to the 10th power. So we basically just have to multiply those two numbers. So x3 to the third, well, that's x3 times x3 times x3. And we can expand it out. And that's x to the 9th. Finally, a to the second, 32 times. We're not going to do that. We're just going to cut to the chase. 32 times is a to the 64th. You're multiplying those two. So do you see the pattern? Yep. Well, when bases are the same. Oh, wait, there is no bases are the same. Scratch that. There is no bases are the same. When raising power to a power, you multiply the powers, or the exponents. So let's just jump to this chase. We're doing 6 times 3 here. So it's 12. 6 times 3 is 18. 12 to the 18th. 4 to the 24th. What are some different ways you can write that? Well, how about 4 to the, what two numbers multiply to get you 24? How about 12 and 2? 4 to the 2nd power raised to the 12th power. Now we could also just do like 4 square times 4 square times 4 square 12 times, but I don't think we need to do that because that's a lot of writing. So I could have done easier numbers too. If you thought 4 to the 3rd times 7, nope, times 8, that would have worked as well. And that would have made this middle part even faster. A5, B4 to the 3rd. Okay, what do we do with this? This one gets a little weird. Well, what we have here is we've got A5, B4 times A5, B4 times A5, B4. What happens when you multiply that all out? Well, you've got like A times A times A times A times A. That's 5 A's. Plus another 5 A's, plus another 5 A's. So you could just write that like 15 times. And then what about your B's? Well, let's look at our B's. We've got B4, which is 1, 2, 3, 4. Plus another 4 B's. 1, 2, 3, 4. Plus another 4 B's. 1, 2, 3, 4. So on. How many A's is that? Well, that's 5 and another 5 and another 5. That's 15 A's. So A to the 15th. How many B's do we have? We have 4 plus another 4 plus another 4. So that's 12 B's. Now, how did I get 15 and 12 from these numbers? Well, think about it's almost like the distributive property. You take this, 3 times 5 is 15, and then we're doing the other double rainbow. There it is, 3 times 4 is 12. So A 5 times 3 is 15, B 4 times 3 is 12, so A 15, B 12. Double rainbow it. Try that to this last one as well. We've got a double rainbow. Oh, it looks like we got a triple rainbow this time. So we're going to go 4 to the x square. X squared to the 4th is x to the 8th, because 2 times 4 is 8. Let's do our second rainbow. 4 to the y5. y5 to the 4th. Well, that's 5 times 4 is 20. And let's do our last rainbow. 4 times z3, or z3 to the 4th power. Well, 3 times 4 is 12, so z to the 12th. So that's it. Here's a formal rule when raising a power to a power. So let's say we have x m to the n is x m times n. Or you could even say x m n. They both mean the same thing. Let's try some examples. These get a little weird, but don't worry, we're just multiplying those two. We got the 6 still. 3 times negative 2 is negative 6. Now, we should be simplifying that because negative exponents are kind of ugly. So remember, we don't want our negative exponents to be negative, so we rearrange them to look like this. We put them underneath a fraction bar. All right? So that's our answer. 1 to the 4th times 2, well, that's 1 to the 8th, times 1 to the 3 times 4. Well, that's 1 to the 12th, I think. Yeah, 3, 6, 9, 12. All right. Now, Can I simplify it further? Yeah, 1 to the 8th times 1 to the 12th. You basically, that's 8 ones times another 12 ones. That's 1 to the 20th, which if you want to simplify it further, what's 1 to the 20th? 1 to the 20th is just 1. But hey, this is a good answer too. Number 3, we have 6 to the 9th on top. That's good. On the bottom, we have to simplify that. 6 to the 3rd raised to the 2nd power. Well, that is going to be 6 to the 6th. On top, we have 6 to the 9th still. Can we simplify it further? Yes. Remember, when you divide, you're subtracting. Now, if you don't remember, take a look at this. Remember, this is like 6 nines. 1, 2, 3. Or sorry, 9 sixes. 4, 5, 6, 7, 8, 9. And on the bottom, you have 6 sixes. 1, 2, 3, 4, 5, 6. And then basically these are all being multiplied together. And what do? Well, you cross off your common factors. So now, what do I have left over? Just the 3 sixes on top, so 6 to the 3rd, which is whatever that is. So remember, you're just subtracting. So 6 to the 9th minus 6 to the 6th, which is 6 to the 3rd. Let's look at number 4. Ooh, look at this. Power to a power, we're multiplying. C to the negative 3 times negative 4. What's a negative times a negative? It is a positive. So negative times a negative is a positive, and that's going to be a positive 12. A positive exponent's a good thing, so we're okay with it. W to the 0 power times times w to the 2nd raised to the 1st power. Well, 2 times 1 is just 2, so this is still w to the 2nd power. And w to the 0 power, you could add those up, because when you multiply powers, you're actually adding them. So that's w0 plus 2, if you want to think of it that way, which is just w to the 2nd. You can also just say, well, you can also just think to yourself, well, w to the 0 power is just 1, so 1 times w to the 2nd is w to the 2nd. Either way, w to the 2nd is your final answer. Number 6, anything we could simplify here? Yes, let's simplify this section right here. 2 times 4, that's going to be t to the 8th. All right, so let's rewrite the whole thing. T times t to the 8th over t to the minus 3. Before we deal with the bottom, let's add up these two, because this is t to the what power? It's basically t to the 1st power times t to the 8th. Remember, because there's 1 here, and then there's 8 more over there, and then you're just kind of adding up your powers. And that equals t to the 9th over t to the negative 3. And remember here, t to the 9th minus t to the negative 3, you're basically subtracting. So 9 minus negative 3, which is basically adding, right? So that's t to the 12th. T to the 12th power. Let's go down to our last couple, our true to false questions. Let's simplify these. Y to the 2nd times 1, that's going to be y to the 2nd still. Y 5th times y 0, well, you can basically cancel out y 0. That's y 5th. It's basically y 5 minus 3, which is y to the 2nd. And does that equal y to the 2nd? Yes, it does, so it is true. I'll just put T for true. Q0, well, that just basically means 1. I could essentially cross it off. Q to the 5th, Q5 minus Q2, which gives us Q3. And this is Q3 times 2, which is Q6 over Q3. And then 6 minus 3 is 3, so Q3 equals Q3. That is true. 9. 8 to the negative 6. Oof, it's an interesting one. Let's do the left side first. 8 to the negative 6 minus 2. What does that equal? That gives us 8 to the negative 8, because we're subtracting. And 8 to the negative 8, let's kind of stop there. We can also just say 8 to the negative 8th is 1 over 8 to the 8th, because that's what a negative exponent is. Let's do this one. 8 to the negative 4 raised to this negative 2 is going to be 8 to the negative 4 times negative 2 is going to be positive. So 8 to the 8th is 8 to the 8th, the same as 8 to the negative 8. It is not, so it is false. Let's do 10, the last of the true and false. This is B1 times B4, which is B5 over B10. Still, because we got the B10 on the bottom. And B5 over B10, that's 5 minus 10, which gives us B to the negative 5, or 1 over B to the 5th. Over here, we've got 5 times negative 1. That gives us B to the negative 5th. Oh, you know what? Yes, this and this are the same. It is true. Finally, using our knowledge of exponent rules, find x, the value of each missing exponent, in order to make each of the equations below true. Find x. This gets kind of tricky. So let's do this. We are going to start off by simplifying what we can. 7 to the 2nd raised to the 9th. You're going to multiply those two. So that's 7 to the 18th. You're going to be left with y to the 3rd times x. Now, remember, you're multiplying that x. What's 3 times x? It's 3x. Y to the 3x. Each. So we're finding the value in order to make each of the equations true. What is kind of odd about this one is that unlike the other ones, and I wonder if this is a typo, because I get the sense that this is a typo. So I'm going to stop there actually on this one, and I'm going to go to number 12 in order, and hopefully we can make sense of this. Let's use our rules to simplify this. Y to the 2nd raised to the power of x is y 2x. On the bottom is y to the 6th. On the other side, we've got y to the negative 7 times y to the 7. Remember, that is y negative 7 plus 7, essentially, which gives us just negative 7 plus 7 is 0, which means basically y to the 0 power is 1. Let's take a look at this side. We have y2x over 6. Remember, we are dividing both of those, so to rewrite it, it's y to the 2x over y to the 6th. All right? And we know that what that means is y to the 2x minus 6. All right. So here's the part that gets weird. The bases are the same, right? Y and y. And then we just have these exponents. What you could do now is basically set this exponent equal to that exponent, because we know the bases are the same. So I need to kind of move over here. So we're going to ignore the base, which is y, and we're just going to write the exponents, the powers. 2x minus 6 equals 0. So how do I solve this equation? Well, you start by adding 6 to both sides. That cancels. You're left with 6, equal sign, and 2x. 2x equals 6. What does x equal? Well, you divide both sides by 2, and you get x equals 3. And that's going to be our answer. So what does that mean? Well, if we plugged that back into our original equation, which is right here, y2 times x. y2 times 3 is y to the 6 divided by y to the 6. So y to the 6 divided by y to the 6 is just y to the 0, which is 1, which is exactly what we got. So what I imagine this was supposed to say is this probably was supposed to say y to the second times 9 is my guess. So it's not supposed to say 7 to the 18th, but y to the 18th. So if we're going back to this, you notice how y to the 18th equals y to the 3x. Since both bases are the same, you can basically ignore it and then just write the powers. 18 equals 3x. Divide both sides by 3. You end up with x equals 6. So 2 times 9 is 18. 3 times what equals 18? It's 3 times 6. So that is how you do a power to a power. Sorry about the confusing number 11. I'm pretty sure that was a typo and that's what it's supposed to say. So go ahead and try some problems on your own. Good